Hey everyone, welcome to this explainer. We're diving straight into a cosmic cold case today, right here in our own solar system's backyard. I'm absolutely thrilled you're here because we're looking at some wild astrophysical research that tries to answer a massive lingering question about our local gas giants, Jupiter and Uranus. To crack this mystery, researchers actually had to simulate a hidden, violently chaotic past, one that involves an entire missing planet. Yep, a missing planet. We're going to look at the evidence of an ancient cosmic hit and run that quite literally changed the map of our solar system forever.
Section 1. A solar system mystery.
You know, when we look out into the deep, dark outer edges of our solar system, it's so easy to think of things running like clockwork. Orderly, predictable, settled down for billions of years, right? Well, actually, the closer we look at these massive outer planets, the more chaotic the physical evidence really appears. Which brings us to a huge central question. Where did these moons really come from? We're not talking about large, tidy satellites like our own moon, nicely orbiting in line with its planet's equator. No, we're talking about irregulars. Jupiter alone has nearly 100 moons, and a huge chunk of them fall right into this category. We're talking swarms of smaller moons orbiting in wild, highly elliptical, and sometimes completely retrograde directions, meaning they literally fly opposite to the planet's rotation. So, how exactly did they get there? When we compare the data for Jupiter and Uranus, we actually get our first massive clue that something catastrophic happened. On one side, you have Jupiter, basically a massive gravitational bully, surrounded by a staggering volume of these irregular, retrograde moons, buzzing around it like a swarm of angry bees. And then, look at Uranus. Uranus is literally tipped on its side, rolling around the sun like a barrel, and carrying this bizarre, tilted system of moons right along with it. For decades, scientists have been banging their heads against the wall trying to figure out what could explain the strangely shattered orbital paths around Jupiter and that wildly tilted neighborhood of Uranus. Well, recent research suggests that chaotic planetary interactions in the early solar system might actually be responsible for both. The data points heavily to one thing: a massive disruption.
Moving on to Section 2. Flaws in the old theories.
As the researchers point out, standard models struggle to fully explain the complex gravitational mechanics and origins of these outer moons. See, the traditional view of our solar system is basically a story of slow, gentle accumulation. The old theory goes, dust became rocks, rocks became boulders, boulders became planets, and the leftover dust slowly coalesced into nice, neat little moons. But that traditional, orderly timeline just doesn't add up with the hard evidence we see today. By simulating the early solar system's instability phase, researchers proved that a peaceful disk of leftover material couldn't possibly create these chaotic outer moons. Think about it. If moons formed slowly and peacefully, they should all be orbiting neatly in the exact same direction. You simply do not get highly tilted or backward-flying moons from a peaceful disk of dust. You get them from a major, violent event. This brings us to Section 3. Enter the lost planet. This is where we get the ultimate plot twist in our cosmic detective story: the introduction of a massive, hidden culprit. We are talking about a literal ghost in the gravitational record, a rogue planet. By definition, a rogue planet is a planetary mass object that doesn't orbit a star directly. They're often ejected from the very system where they formed. But guys, this wasn't just any small rock. Researchers strongly suspect this lost world might have been an ice giant, very similar in size and makeup to Uranus or Neptune. It existed right here, in our early solar system, fighting for space among the giants, in this epic gravitational tug-of-war, before being violently kicked out. Astrophysics proves time and time again that planetary formation is a ruthless game of gravitational musical chairs. And sometimes, a massive ice giant simply loses its seat. 4.5 billion years. That's how long this secret mechanism of planetary evolution has been missing from our models. For 4.5 eons, this lost planet has been completely gone, entirely erased from the crime scene, leaving behind only these strange gravitational fingerprints on Jupiter and Uranus. It is just wild to think about, right? Our solar system used to have an entirely different family portrait, one that included an extra massive sibling that was ultimately banished into the dark. Let's look at Section 4, a game of cosmic billiards. To really understand how this rogue planet gave Jupiter and Uranus their moons, we kind of have to visualize early space as this chaotic, high-stakes game of billiards. In Step 1, the massive rogue ice giant approaches, acting exactly like a cue ball smashing into a perfectly structured rack of early planetary material. Step 2,
Its sheer gravitational bulk is enough to absolutely shred the orderly space rocks, the primordial planetesimals, that were orbiting out there. This rogue planet essentially perturbed the orbits of these ancient, icy bodies, scattering them wildly. And then, for step 3, the gas giants capture that scattered debris gravitationally, creating the moons we see today, all while the lost planet itself is sent flying away.
So in the aftermath, existing orbital paths were totally disrupted. The rogue planet swings by Jupiter, its immense gravity tearing apart nearby icy bodies. Jupiter then captures this violently scattered debris cloud, locking those fragments into those weird, backward, irregular orbits we talked about earlier. Then, keeping with that pinball trajectory, the rogue planet swings past Uranus. It disrupts that system so violently, it actually solves our dual mystery. It explains Uranus's bizarre sidewise tilt, while also allowing Uranus to capture its own strange moons. Finally, we get the dramatic ejection. The rogue ice giant gets slingshotted by the immense gravity of the gas giants, ejected entirely out of our solar system and into the deep, freezing void of interstellar space.
And that leads us to Section 5, Rewriting Planetary History.
Look, this changes everything we thought we knew. It demands a total shift in our understanding of planetary evolution. We literally have to rewrite the textbooks here. The big takeaway for you is that the history of our solar system was not some peaceful, orderly formation, but a chaotic, violently dynamic battleground. Our cosmic neighborhood was shaped by dramatic, hit-and-run planetary migrations rather than just slow, quiet gravity. When you look up at Jupiter or Uranus through a telescope, you aren't just looking at planets that calmly grew into their current, majestic states. No way. You are looking at the battered survivors of a cosmic brawl. This totally upends the peaceful models of our solar system's youth and shows us just how violent planetary architecture really is.
So here's the final question to leave you with. If our solar system kicked out an entire giant planet, what else is hiding out there in the interstellar dark? It leaves us looking up at the night sky with a chilling yet totally fascinating realization. If a massive, fully formed ice giant was just tossed out of our cosmic backyard billions of years ago, it means it is still out there somewhere, drifting, lightless, starless, and completely alone through the Milky Way. It really makes you wonder how many other rogue planets are wandering the void right now, holding the lost histories of other solar systems. Thank you so much for joining me for this explainer. Keep asking questions, keep challenging the standard models, and as always, keep looking up.